Hello, everyone. This is Marlene McKenzie from Earth's Treasures. This is my first video, and I have some PowerPoint slides, which are my very first two to share with you today. The topic is foods and botanicals to support the immune system. And there are a couple of typos in the PowerPoint presentation papers, so I will point them out as we go along. Uh, First, before we get to the foods and the botanicals, we need to talk a little bit about the immune system. We need a little bit of an understanding about it so we know how foods and botanicals affect it. And first, I'm going to give a general definition. It's just a group of organs and cells that actually help to work together. They work together to recognize or distinguish self from non-self. Non-self being anything foreign that comes into our body, and that is considered a breach to our body. It's not normal, and our body is going to look at it as a foreign substance, and it's going to take care of it. And that's what the immune system is. The immune system is divided into two different divisions, and each division is divided after that. I'm just going to try to briefly go through them. The first one is the nonspecific or innate, and the second is the adaptive or specific division. Both of them are overlap. They're not separate entities. They work together to form an optimal immune system. So the first one we're going to go over is the innate or nonspecific. It's always there and it's always ready to go. It's very nonspecific. It's one of the first things is our barriers, such as our skin, our mucous membranes, hair, eyelashes, the cilia, in the respiratory tract. We have acid environments in our body that are created to help control or destroy bacteria and pathogens when they get in. And so there's these acid environments created in certain areas of our body, and they are in our GI tract, stomach mostly, they're in our vaginal tissues, and they're also in our urine. And again, acid protects us from the bacteria by helping to provide an unwelcome environment for them. We also are covered by good bacteria in our GI tract and our vaginal tract, and also in our respiratory tract and all over our skin. We have billions and billions of bacteria and fungi that actually help us work and perform functions we actually need them to help. Then we have mucus, which is secreted by saliva, tears. We have sweat, and we have gastric fluid. The mucus contains a secretory IgA. This is an antibody that is produced in the plasma cells, which are right adjacent to mucosal cells. And this is increased when we are infected in our mucous membrane. That's why we have a lot of mucus production. And it's there to help to signal the immune system and to also protect us with our mucous membranes with different bacteria and things coming in. And one other thing that we have that's pretty non-specific is a development of a fever or an increased internal temperature, and that's actually a protective mechanism because when an organism enters our body, the fever is generated, and that makes it hard for them to survive. A note here on fever reducing drugs. I use them, you want to try to use them with caution. Uh, a very high fever is fine, but continual use of fever reducing meds are not really that great because you're actually preventing the body from developing that environment for the organisms not to survive. So you actually want a little bit of an increased internal temperature. Um, in the botanical world, there are botanicals that are called, they have properties that are called diaphoretics. And diaphoretic is an herb that helps you sweat. And the sweating is helping you to reduce your internal temperature, but it's a more natural way of doing it. And generally, herbalists use it in a formula when you're sick, say with a cold virus, and you're developing a very high fever, as could you with COVID. Then they would give you not only an antiviral and maybe a couple other herbs, but also a diaphoretic to help your body to keep its internal temperature down a little bit. It's not they're not going to it's not going to greatly reduce your fever as a pharmaceutical would. And then last but not least, there's an enzyme that's produced in most of the body fluids called lysozyme, and it actually breaks down bacterial cell walls. So what a lovely non-specific thing to encounter when you're a bacteria and you're entering in our bodies. And here is this lovely enzyme that actually is going to break you down, and then you're going to be able to be killed and phagocytized, which we're going to talk about in a minute, by other cells of the immune system. So that is the barrier defense of the nonspecific immune system. And then we have non-specific cellular defense. So you have the barrier and then you have the cellular defense of the innate systems. And the cellulars is a group of cells react to a broad group of infection agents, and they are neutrophils, macrophages, eosinophils, basophils, mast cells, and natural killer cells. Macrophages, they reside in our tissues, and when they are signaled, they are moved into the blood system, and them, along with the neutrophils, go into the infected tissue to gobble up the bacteria. And that's what I meant earlier by phagocytosis, is the organism, the bacteria is actually being gobbled up by our immune cells. And that is the neutrophils and the macrophages. Then they also, they do kill and they eat and phagocytize a lot of them, but they also present these bacteria to other white blood cells of the adaptive immune system. And they present them, and they call them antigen presenting cells. And so they eat some, but they also present other ones to our adaptive. And that's one of the ways I was talking about earlier, how they communicate with one another, because they might not be able to handle the whole job themselves. So they're going to now signal the adaptive immune system to come in and help them out. And the adaptive immune system produces our antibodies, which gives us our long-term immunity. So that's how it all starts, though, is with our nonspecific immune system. So we have these antigen-presenting cells that present these bacteria and bad pathogens, which are considered the antigens, to the other immune system, the adaptive immune system of our body. We also have eosinophils that secrete an enzyme to digest mostly parasites. If the parasites are too big, then what they'll do is they'll tag them for other immune cells to come and take them and destroy them. Basophils have histamine in them, and when they get a signal, a chemical signal, there's a lot of different chemical signals going on in the immune system. They get a signal to release their histamine, and what that does is it increases the blood flow to the area. They also attract in eosinophils and neutrophils to the area. So they're bringing in the blood flow more, and then that's attracting in the eosinophils and the neutrophils, all to mount a response to this antigen or pathogen. The mast cells, they live in the tissues, and they release histamine due to an allergic reaction or inflammation. And inflammation we're going to talk about in a little bit later, and how important that is for our bodies. It's actually important. And then last but not least of this, the immune cells is the natural killer cells. And they kill cells and lyse them when they are infected with viruses or cancer cells. So, you could have some cancer cells starting, and the natural killer cells will detect them out, be signaled that there is some abnormal cells starting, and they'll go in and they will start killing the cells. And this actually happens every day in most of us, and our bodies take care of these cancerous cells if our immune systems are healthy. And as you can see, with all this gobbling up and phagocytizing and tagging and killing off all these bacteria and pathogens, there's a lot of waste being created, which our immune system has to handle, and our lymphatic and circulatory systems have to encounter first before they get excreted or going through the colon and out into our feces. So that is the non-specific cellular defense, the barrier and the cellular defense. And now what I'm going to go into is the adaptive immune system. The adaptive immune system is specific. It needs priming. It's a lot slower than the innate system or non-specific. It takes a little while longer because it's developing the antibodies and memory to the invaders or the pathogens in the body. It's also not localized. It's a body-wide reaction. Okay, so as I had mentioned earlier, the adaptive immune system is called in after our innate or our non-specific immune system has encountered the pathogen. Then by chemical signaling, the adaptive immune system is signaled, and they start their slower response. They are active. The adaptive immune system is active against intracellular viruses, tuberculosis, leprosy, syphilis, brucellosis, and Lyme. It's active against fungi and tumors, various protozoans, and also chemicals that we put on our skin topically, and or that we ingest, and also organ grafts, which is an organ graft is considered not self. It's considered a foreign tissue. So it's actually, the adaptive immune system is actually active against that too. And that's why they get a lot of organ rejections when they transplant an organ, is because of that. Now, the adaptive immune system is divided into a cellular and humoral. And the cellular is mostly T lymphocyte cells, and they mature in the thymus gland and then are released They recognize yourself from the pathogens. And there's actually, I think I wrote down 3 different types on the paper, but there's actually 4 different types, and that's T helper, T suppressor, T regulatory, and T cytotoxic. And you can pretty much go by what they're named, by what they do, what their functions are. But again, they have direct functions, but then they also have indirect functions. Everything is an interplay here. The humoral system is mostly the B lymphocytes, and these are the guys that make the antibodies against the pathogens. They retain the memory, and the way they do that is they get the signals from the T cells. Chemicals are released from them, and then they signal the B cells to divide and make memory cells and also effector cells. And the effector cells are the ones that are actually going to attack the bacteria at that particular moment, and then the memory cells are going to be there for if they ever see that specific pathogen again, there's going to be antibodies already. The antibodies will be made instantaneously, and that is what we actually call immunity, is when the body has antibodies that have been made previously to a pathogen, and when they are introduced again, the pathogen to the body, the antibodies are automatically made. And this takes a while, and that is what we call immunity. Let's see. Well, let's see. We have the cellular and we have the humoral. We have the T cells and we have the B cells. We also have organs in our adaptive immune system. And the organs are the lymphoid tissues, the lymph nodes, where the white blood cells travel and hang out. Sort of like hang out in your lymph nodes waiting for these pathogens to come in. And, when you get sick, that's why sometimes you get really infiltrated. There's a lot of white cells being collected in that area because they're trying to fight the pathogens, and so you get enlarged lymph nodes. You also have tonsils and adenoids, the lymph nodes, and the vessels, the actual lymph vessels, where the lymph is traveled through, and then all those different cells of the immune system travel through that lymph. You have the thymus, where the T cells are matured. You have the spleen, and you have the appendix and Peyer's patches. Peyer's patches are little lymphoid tissues, residents that are in the GI tract, or next to the GI tract. And that is because a lot of pathogens are encountered in the GI tract. So we have an extra reserve of lymphoid and cells waiting there in the Peyer's patches. Also, the appendix on the colon, right before the colon, is we have a lot of pathogens there too. Okay, so a couple little tidbits. 70 to 80% of your immune system lies within your gut. And that is all those good bacteria and fungi that are in your gut. The bone marrow is where the immune cells are made, and the blood system is where the immune cells circulate. And then the lymphatic system is actually attached with the circulation system. So it's the lymphatic, the blood system, and the lymphatic system. That's what I mean by the blood system, where they circulate. Now, inflammation. Inflammation is actually a good thing when it is encountered short term and not long term like we have nowadays everywhere. But short term, it's actually the body's attempt to protect itself and clean up the area and rebuild the tissue. And What happens is when you get tissue damage, there's a lot of chemicals that are released to signal um, the capillaries to become leaky. So that brings in more blood flow. When more blood flows come in, more neutrophils are coming through, and various immune systems are coming through into that blood flow, and those macrophages in the tissues are activated, and they are released into the blood system along with the activated T and B cells. So what happens is in inflammation is all this excess blood flow in the area, which is a good thing because it's trying to bring all those immune cells in and take care of what's going on in the area, produces a lot of excess fluid, and that excess fluid produces a lot of swelling, which activates the pain receptors in the area. We all have pain receptors in the areas of all our body, and that's what happens, and that's why we feel that pain with inflammation. But it's a good thing as long as it's short term. Like I said, it's your body's way of protecting itself.